In this video, I would like to show you how to use a multimeter. Now, this is a typical multimeter, and the reason why we call it a multimeter is because it can measure different quantities. For example, we can measure voltage, and for the voltage, the symbol V you can see, and we can measure AC voltage, so alternating, so a voltage that changes with time and it changes its direction. We can measure DC voltage. This setting is for a voltage which is very weak or very small amount of voltage that we want to measure, so it's millivolts DC. And over here we have a few different functions. You will see the ohm sign, and this is for resistance, so we can measure resistance, and we can measure a capacitance, which is CAP for capacitance. We can also test a diode, which is this symbol of a diode, and it can also be used as a buzzer. And we use this buzzer to see the conductivity or verify connectivity of 2 points, and we will see that later how this can be done. We can also measure frequency, which is this symbol, Hertz, and the percent symbol is for measuring the duty cycle. For example, if I want to see uh, a square or a rectangular waveform, and for how long the waveform is on and for how long it is off. So these are various different functions that we can measure using the probes in this setting. As you can see, the red one, which is the positive terminal typically, is connected over here, where you can see all these symbols, voltage, resistance, ohm meter, and so on. And the black one is the common or ground, and that will be the same for all different measurements. So all these functions that we have discussed so far, we will keep the probe in this location. But when we are measuring current, so we have in this multimeter, I have these three different options. The first one is 10 ampere. So if I want to measure a large amount of current, then I will use this setting, 10 ampere. And when I'm measuring 10 ampere, then I will have to bring the red probe to this location, which says 10 ampere. On the other hand, if I'm measuring a small amount of current, for example, milliamperes or microamperes, then I will use this location for the red probe. So all we need to do is to take out this knob and remove the probe, the red probe from here, and just insert it over here. And with this setting, now we can measure the current. So make sure that you switch the position of this probe depending on what quantity you are measuring. So now let's get started, and we will measure a resistance first of all. So I will move the switch to the resistance location, and you can see that we have a few, it says the range is auto, and right now we are going to measure resistance. And at the moment, I'm not measuring anything. So let's see how we will measure resistance. Now, these are the two probes that we talked about, the red and the black. And for a resistor, it doesn't matter because resistor doesn't have a polarity. So this resistor will behave the same way if I connect it this way or if I connect it this way. So it doesn't really matter because it doesn't have any polarity. Both terminals behave the same way. So if I want to measure the resistance, all we need to do is to connect the probes with the two leads of the resistor. And I will try to use only one hand. If I touch with both hands, then actually we are measuring the resistance of this resistor as well as my own resistance. So therefore, that will give me wrong values. Now here, I would like to show that we are measuring right now a value of 984 or 991 ohms. And this is actually a resistance value of 1 kilo ohm because it is brown, black, red. So brown, black, red means 1000. So that's 1 kilo ohm resistor. And we can see from the multimeter, when I measure this resistance using the probes like this, we can see 983 ohms. So this is how we will measure resistance. Now let's say if I want to measure capacitance, so all we need to do now is to press, because the capacitance will be measured at the same knob location. So all we need to do now is to press the mode button so that we can go from resistance to capacitance. And over here, we have a diode symbol. So this is not a capacitor, this is a diode testing. And now here we have a buzzer symbol, which means this will act as a buzzer. So for example, if I touch the two probes, it will beep. So we can use this feature and connect the probes at different points in our circuit to verify if those 2 points are connected together or not. So this is a convenient way of not looking at the meter all the time. You can just touch the 2 points, and if you hear the beep, that means those 2 points are connected, or the resistance between those 2 points is 0 ohms. Next, let's measure capacitance. So I will press the mode again, and now this is the capacitor setting. And right now we have no value. So if I want to measure a capacitance, so I have this polar capacitor. It is 10 microfarad. I'm not sure if you can see it, but it is 10 microfarad capacitor. All right, so let's see what our meter will tell us. So the meter is saying 10.35. Let me try to show you again over here. And it is 10.34 microfarad. So it's not that the meter is given an incorrect value, it's just that every capacitor will have a slightly different value. They cannot be exactly 10 microfarad. All right, so we have seen resistor and capacitor. Those are the two very simple functions that we can measure. The next thing I want to measure is DC voltage. So if we want to see the DC voltage, I will put the probe, the switch at this location, which is DC voltage. And let's see how correctly we can measure our voltage. So right now I have this power supply over here, and we have 5 volts DC. So I want to see if this supply is producing a voltage that can be reliable. So these are my probes of the power supply. I'll connect the black probe with the black of the voltage power supply, and the red one with the red probe of the power supply. And now you can see we have 5.14 volts on the multimeter. And on the power supply, we can also see about 5.0 and then 5.1. And the other display on the power supply is the current in milliamperes. So you see this is current in milliamperes, and this is the voltage. Now, because my power supply is open circuited, as you can see here, there is nothing between the red and the black. So the resistance between these 2 points is infinite. So therefore, there is 0 current flowing. And therefore, on my display over here, I have 0 current. But the important point that we are discussing right now is that voltage from the supply is 5.1, and the meter can show me 5.14. So they agree pretty well. Now, if I change the voltage, for example, if I change the voltage of my power supply, if I increase it to, let's say, 6, and I see on the meter it follows. So now I have 9, 10, 10.2 volts, and on the meter is the same. So this should give you some confidence that you can measure the voltage pretty easily using the voltmeter. Also, sometimes people will call it voltmeter. So when the multimeter is used as a voltage measuring device, then we will call it a voltmeter. And when we are measuring the current, we will call it an ammeter. And when we are measuring resistance, sometimes we will call it ohmmeter. All right, so we have these different values of DC, and you can see that the voltage on the meter follows that accordingly. All right. Now I would like to discuss how to measure voltage and current in your circuits. There are a few simple rules that we need to follow to make sure that we use the instrument safely without damaging the fuse inside the multimeter. So what I want to discuss is that, let's say we have this simple circuit where I have these 2 resistors connected. So let's say this is R1 and R2. And I have a voltage supply of, let's say, 5 volt. Now, if I want to measure the voltage across resistor R2, so let's call it V2. So if I want to measure the voltage across R2, how do I connect the multimeter? Now I would say that, okay, I need to know the voltage between this point and this point. So we need to know the voltage between these 2 points. So what we will do is that we will connect our multimeter in this way, that this is the positive terminal of the voltmeter and this is the negative, and I'm going to measure the voltage like this. So the probes are going to be connected between these 2 points, and this will give me the voltage across R2, which is V2. Now, this causes some confusion time to time. Sometimes we can get confused that how about if I connect the voltmeter in this way. So this is my voltmeter, positive and negative terminal, R2 and R1, 5 volt. Now this is incorrect because here the voltmeter is in series with the resistor R2. This is the correct way. And here the voltmeter is in parallel with the resistor R2. So we need to remember then that when we are measuring the voltage, the voltmeter has to be always in parallel with the component across which we are trying to measure the voltage. And there is a very basic, simple reason behind it, which we will explain in a little bit. But the first thing is that if I connect the voltmeter in this way, now the voltmeter has no idea how much is the voltage here, right? If the meter has to measure the voltage, the meter needs to know what's the voltage at this point. Now, if I connect the meter in this configuration, the meter has no idea what's the voltage on top over here. So therefore, the meter will never be able to tell me what's the voltage. All right. Now, why do we need to put it in parallel? That's one reason. And let me discuss another point over here, is that let's say, again, the same circuit, if I have 2 resistors and I have 5 volts over here, I want to measure V2. This is V1. From here to here is V1. From here to here is V2. If I want to measure V2, I will use a voltmeter. Now, when I connect the voltmeter should not change anything in the circuit. It should not change V2. It should not change V1. The current in the circuit should remain the same. Everything should remain the same, because if I disturb anything, then my measurement is incorrect. So every time if I connect a meter, and if any quantities changes, then this means we are not actually measuring the actual voltage at that point because the meter is changing it. So how can we measure this voltage without changing it? So the idea is that I'm going to connect something over here. Let's say this is my voltmeter. I'm going to connect a voltmeter between these 2 points, but this meter should not draw any current from the rest of the circuit. So the current that is going to flow through the meter should be almost zero, means it should be very, very small. And this can happen if you can imagine that there is a resistance which is very large. So let's say approximately almost a giga ohm, right? So extremely large resistance. So this large resistance is in series with my voltmeter, and the voltmeter is some kind of a sensor which will measure the voltage. So therefore, the current that will flow in this path will be so small that we should be able to neglect it. Okay, so the current in this path is zero. And if the current in this path is zero, then this meter will not change my circuit. And therefore, V2 will be almost the same as before we connect the voltmeter. So therefore, you should remember that a voltmeter has a very large resistance in series with it. Okay, so it's a very large resistance and it is approximately equal to an open circuit. Okay, so we can think of it as an open circuit or infinite resistance. So therefore, it will not change the voltage V2 in the circuit. And now it will be able to measure, because the voltmeter now knows how much voltage we have here and how much voltage we have here. Now remember, this is the red probe of the voltmeter and this is the black one. We always use the red for the higher voltage and black for the lower voltage. It's a convention. It doesn't make your results wrong if you do the opposite way, but it's just a convention. All right, so this should be able to give us the voltage across R2. Now, this introduction of the voltmeter, you should be able to now see what will happen. For example, if I have this DC power supply, 5 volts and V2, and if I put the meter over here in this way, right? If I do this, now what will happen? Now you can see that the voltmeter has a very high resistance in series, okay? It's like an open circuit. So this circuit is actually this way, that you have a power supply and one resistor and another resistor and then a huge resistor. this is almost infinity. And this is whatever ohms you have, R2, R1, and 5 ohm, right? So you have a huge resistance. And after that, you have the voltmeter, of course. So now you can see that in this circuit, the resistance is very, very large. So the current flow will be zero. The current will be zero. And therefore, the voltage drop across R1 will be 0 volt. The voltage drop across R2 will be 0 volt. And this is your multimeter. You see from here to here is your multimeter. And therefore, the voltage drop across the multimeter from here to here will be 5 volt, which is the source. So the meter will tell you 5 volts. And this is all the voltage of the supply because the current is in the circuit is 0. And this is not the voltage across R2. This is just the supply voltage. All right. So now let's take a look at all of this and let's see how much voltage do we measure and how much voltage do we expect to measure. All right, so here I have created this simple circuit where I have two resistors, R1 and R2, and they are connected in series. Just to show you, if you could see how it looks like, probably this angle. And both of them are 1 kilo ohm resistors. So they are equal resistance. So because the resistances are equal, therefore we should expect equal amount of voltage drop across both of them, and they are connected in series. So whatever the supply voltage will be, it will be divided half between them. So now let's see. I will put the supply voltage to be equal to 5 volts. All right, so now my supply voltage is 5 volts. And first of all, let me measure the supply voltage. And it is 5.01 on the multimeter, 5.01. Now, if I want to measure the voltage across R2, which is this one, we should expect that it should be half of 5 volts. So we should measure 2.5 volts. So you see, I will connect one probe on one side of this resistor and the other probe on the other side. And now my multimeter is in parallel with the resistor. And if I do this, the voltage on the meter is 2.5 volts. And this is correct. You can see this is the voltage across R2. Voltage across R2 is 2.5. And similarly, if you want to measure the voltage across R1, you will connect the positive terminal over here and the negative on the other side of the resistor. And this one is also 2.5 volts. So you can see that the voltage of the supply is divided in two, and each one has half of the voltage. Now, as I said earlier, what if I incorrectly place my multimeter in series with R2? So if I do that, this means I'm connecting one terminal of the multimeter over here, right? So that's the negative. And I'm connecting the positive to the resistor. So if I do this, and now you see I'm measuring 5 volt. And that's what we said, the meter will measure 5 volt because the current in the circuit is 0 and the voltage drop across both of those resistors is 0. So therefore, all of the voltage is actually dropping across the multimeter. And you can see that the multimeter is actually causing this circuit to become an open circuit, right? There is no path for the current to flow. The multimeter has a resistance of infinity. So therefore, the multimeter cannot be placed in series with the circuit. Now let's take a look at how we can measure current using the multimeter. So if I want to measure the current, first of all, let me draw an example. So I have this circuit. Let's say 5 volts again. And I want to measure the current through one of these resistors. So this is R1, R2, and R3. So I want to measure the current, let's say, flowing through the resistor R3. So this current, which is I3. So if I want to measure I3, I will have to place my meter in such a way that the current through R3 and the current through my meter are the same. Okay, so the same current has to flow in both of these components. Then my meter will actually give me the correct result. So the way I can do that, as we know, that when two components are in series, they have the same amount of current flow. So what I will need to do is that I will have to place my meter over here. Now this is a current meter, so I will write A inside, so we will call it ammeter. Again, R2, R1, and R3. So the current I3 that is flowing in the resistor R3 is also flowing in the meter. So this is the red probe, and this is the black. And now you can see that the meter and the resistors are in series, so therefore they have the same amount of current flow. So therefore, whatever the meter displays now actually is the current through R3. So therefore, you have to remember that the ammeter has to be connected in series with the component where you are trying to measure the current. So therefore, the ammeter has to go here. Now again, going back to the same logic, the current in R3 should remain the same with or without the meter, right? The current in R3 should not change. If my meter changes the current, then that's a wrong measurement, because the meter is telling me something else and the original current that was flowing in R3 was different. So therefore, the meter should not make the current to change. Now, how is this possible for the meter to do? So for example, now you can think of the same circuit, and we will say, okay, this is such a way. Now the meter that I connect here, okay, the meter that we connect here should have zero resistance, okay? So I should have a ammeter, which will have very low resistance, okay? So the resistance of the meter is almost 0 ohms. If that's the case, then the current I3 over here will not change, because the resistance in this path did not change. You see, I added 0 ohms to R3. So if I add 0 ohms to R3, this means R3 doesn't change. And if R3 doesn't change, therefore I3 will not change as well. So therefore, then an ammeter has a very, very small resistance, almost 0 ohms. Okay, so therefore, the current I3 will be measured correctly by the ammeter. Also, you can see now, if I take the meter from here and put it over here above the resistor, it will not change anything. The current I3 will still flow in the meter, so therefore I will still measure the same current I3 that is flowing in the resistor R3. So we can place the meter either here or we can place it on top. It doesn't make any difference. Also, if I want to measure the current in R2, I will have to place the meter over here. And if I want to measure the current in R1, I can place the meter over here. So wherever you want to measure the current, you will have to place the meter in series with that component, and that will give you the current. Now, one word of advice. Let's say you have your circuit this way. You have two resistors, R1 and R2. And if you connect by mistake the ammeter over here, okay, if you do that, then actually, as you know, that the resistance of the ammeter is 0 ohms. Now you have a 0 ohm component in parallel with resistor R2, and you know that their equivalent resistance will be R1, R2 divided. So this resistance times this resistance divided by the sum of them. So the equivalent resistance, the net resistance of these two will be 0 ohms. So your meter is actually shorting R2. So R2 is actually not there. All the current will flow through the meter, and there will be no current in R2 because the meter is actually shorting R2. Now this is wrong. It will give you wrong results, but it's not dangerous because R1 is limiting the current from the supply. So you have a resistor which is limiting the current, so it is still not dangerous. But this would be very dangerous. If you have a circuit like this and you put a ammeter over here, let's say this is R1. Now this R of the meter is 0 ohms. So now you are actually shorting the supply, right? So the supply is actually connected to 0 ohms. So this is shorting. And now the current from the supply will be huge. And all that current will flow through the ammeter. And this can damage your meter as well as your power supply. So be very careful when you are working with ammeter. Now let's see if I can construct this circuit and I want to measure the current through R3. All right, so I have created this circuit with these three resistors, as you see over here. Let me try to see if we can focus this. So the positive of the power supply is connected to resistor R1, which is 1 kilo ohm. Then that is connected to these two resistors. They are in parallel, R2 and R3. And R2 is 1 kilo ohm, whereas R3 is, let me see, it's 3.3 kilo ohm. So it's orange, red. So that is 3.3 kilo ohm. Right, so now I have constructed the circuit, and you can see that the current will flow through these resistors, and then the current will divide between these two resistors, and then it will go to the negative probe and go back to the power supply. Okay, now let's say I want to measure the current in this resistor, 3.3 kilo ohms, right? So I want to measure in this resistor. So what we need to do is now to put the current meter in series with this resistor, right? So I need to put the meter in series with this resistor, and for that I will have to break the circuit, right? So I'll have to disconnect from here. At this point, I'll have to disconnect from this point and insert the meter here. Okay, so let me do that. So I disconnected this resistor, I removed it like this. So now this point is not connected to this point. You see, this point is not connected to this point. Okay, so now, first of all, I just want to measure my voltage from the power supply. And the voltage is 10.12. That's okay. Now, to measure the current, what I will do is that, because my current is small, so I will use the milliampere. So let's take the probe off from here and connect it over here. And now we will go to milliampere. Over here we have milliampere. And to insert the meter in series, I will put the black probe of the meter on the power supply, black, and the red one on resistor R3. Right, so now in this way, my meter is in series with R3. And you can see the current in R3 is 1.33 milliamperes. 1.33 milliamperes. Okay. If I now see R3 was larger resistor. So the current through this resistor would be large compared to the current in R2. R2 is only 1 kilo. Therefore, I should expect that more current should flow, approximately like more than 3 times current should flow in R2. So let's check that. What I can do now is that I can remove the negative of the power supply from R2, and I will connect the negative over here to R3. So now this will just make the circuit that, so now R2 is kind of isolated. And now I will connect R2, the meter, to the ground. So I'll connect the red over here and the black on the power supply. So now we are measuring the current through R2. And the current through R2 is 4.45 milliampere. All right, so 4.45. So this current, and earlier we measured 1.3 milliampere, so that's 5.7, about 5.7 milliampere total current flowing. And just in case, if I want to verify that is that actually the current that is flowing, so I can actually measure the current that is flowing from the power supply, the total current. So let's put it back, these two together. So now I just want to verify how much is the total current flowing from the power supply. So I will disconnect the power supply from here because I just want to insert my current meter in series with the power supply. So let's connect the red terminal over here. So now the current will come out of the power supply and it will enter the meter, and then it will come out of the meter at this point, and then it will go to the rest of my circuit. And you can see 5.7 milliampere as we expected. 5.7 milliampere, that's the total current coming out of the power supply, and it is dividing between these two resistors that we measured earlier. And you can also see from here, the power supply is telling me that the total current that is being generated is 5 milliampere. It's actually more than 5 milliampere, but the display on the power supply does not show us after the decimal point. So the correct value is 5.79 milliampere. All right, so that's current measurement. The multimeter can be used to measure frequency as well as the duty cycle. And you can also measure the diode test and so on. And these functions are pretty straightforward, so I'm not discussing them here. That's it for today's video. I will see you next time.